Okay, welcome back to the second part of graphing analysis using integrals. So the second part reads, the graph above represents the function h prime of x. Use the graph to answer the questions below. H of 0 equals 5. Okay, and then A reads, find the respective values of h of 2, h prime 2, and then h double prime of 2. Okay, let's see. So this one represents h prime x, right? Okay. And then you're trying to find h of 2. Okay. So h of 2, or h of x, can be found by taking the integral of h of x, right? So, let's see, integral of h of x from, since we have a known value for h of 0, we can use 0 as one of our limits, and then we can use 2, since we're trying to find that value, dx, which is equal to h of 2, right, fundamental theorem of calculus, minus h of 0. And then to find h of 2, we have to do h of 2 equals, push this to the other side, h of 0 plus 0 to 2, h prime x dx, right? Okay, and then now let's find the area under the curve of the h prime of x graph from 0 to 2. 0 to 2, we have 3, or this is like a trapezoid, right? So we have 1, and then we have 2. So add those two together, that would be 3 times the root of 3 divided by 2, which is 4.5. Okay, so we got h of 0 plus 4.5. H of 0 is 5, so 5 plus 4.5 would be 9.5. So we got the first value. H of 2 equals 9.5. Okay, and then now we're looking for h prime of 2, right? Well, h prime of 2, we can just find it by plugging it into the graph. And then, well, h prime of 2, we found it at 0, right? At 0. I'm going to write it right here. Okay, and then h double prime of 2. So h double prime of 2 can be found by, like, the derivative of h prime of 2, right? So, let's see. So we can see that this is a straight line, right? So taking the slope of the straight line would equal to the derivative of h prime 2, right? So that's exactly what we're going to do. We're going to take the slope of this line, because this line contains 2 right here. So the point is 1 and 3, right, over here. And then we also have 3 and negative 3. Okay. So h prime of 3 minus h prime of 1 is negative 3 minus 1 equals negative 3 minus 3 and then 2. This would be negative 6 over 2 or negative 3. So we found h double prime 2 to be negative 3. Okay. Okay. And it says g of x equals integral from 0 to x h prime t dt, and then find the points of inflection of g of x on the interval 0 to 12. Okay, so this is going to be pretty similar to what we did before. So taking the derivative of an integral, you're putting the x into the inside function, so you're going to be left with h of x, right? Okay, so g prime x equals h prime x, and then g double prime of x equals h double prime of x as well. So we're trying to find the points where g double prime x changes signs, but this is also when f double prime of x changes signs, right? This means when, okay, so when h double prime of x is changing sign, this means when h of x is changing from increasing to decreasing, vice versa, right? And since we have the graph of h prime x, we can see where it's increasing to decreasing and decreasing to increasing, right? So let's see. So here it's constant, so no need to talk about it. And it's decreasing, right? And then it's constant again. And then it's increasing, right? Increasing, still increasing, increasing to decreasing. So we have 1 point of inflection at 10, 2. So g of x has 1 point of inflection at 10, 2 as the g double prime x equals h double prime x changes signs since h of x is changing, increasing to decreasing, as the g of x, meaning okay, yeah. And then part C, it says find a point x where the maximum value of g of x occurs. So maximum value of g of x, we can first find the endpoints and also find the critical points or relative extremas. And then g of x equals, again, we're just going to do this again. G of x equals h prime of x, right? Okay, so we're trying to find the points where, or like the critical points first. So this is when h prime of x is equal to 0. It's equal to 0 at x equal 2, and then x equals 8, and we also 12, but then 12 is already there because it's an endpoint, so we're testing everything. So 2, 8, 12. Okay. First, it's going to be 0, 2, 8, 12. Alright, okay. So, let's see. From 0 to 0, 0 to 0, from 0 to 0, h prime t dt is equal to 0, right? And then 0 to 2, h prime of t dt equals, and from 0 to 8, h prime of t dt, and 0 to 12, h prime of t dt. Okay, let's see. 0 to 2. 0 to 2, I think this one, we already found it, right? We already found it to be 9.8. No, we already found it to be 4.5. So this is 4.5 greater than 0, and then 0 to 8 would be... Okay, let's try to see. Well, we can see that this part is the same as this part, right? So it cancels out because one is positive, one is negative, right? And then we have negative area. So that means that, 0 to 8, it's going to be negative, which is already less than x equals 2. So that's not our, or we can just say this is, yeah. So this is not our best shot. And then this one's probably not our best shot as well, since we already have a 4.5. And then 0 to 12 of h prime of t. Let's see. And then we just cancel this one out, and then let's try to find the area of this. 1 plus 4 times 3 over 2. That's 7.5 negative. Okay, so yeah, that's right. Negative 7.5 right here. And then we also have a semicircle. So the radius is 2. So 4 pi squared. No. pi r squared is the area, so 4 pi would be the area of the whole circle, but then it's a half circle, so divided by 2 is 2 pi. So let's try to see. 2 pi equals 6.28, and then minus 7.5, so that is way less than 4.5, as this one is also going to be a negative number, right? So our maximum value occurs when x equals to 2. Okay, so our maximum of g of x occurs at x equals 2 as g of 2 equals 4.5, which is the greatest out of all critical points and points. Alright, so that would be our answer. Okay, thank you for watching this video.